Okay, so this is CYU number 3. It says determine the exact values of the trig ratios for 1035 degrees, and then determine the approximate values of the trig ratios for 1035. Give the answers to 3 decimal places where necessary. All right. Okay, so this is page 441. Okay. Uh, to find the exact value of the trig ratio for 1035, what I would suggest is you get the principal angle and then find the trig ratios for that. Okay, so let's see, 1035, that would be like, hold on, that would be like going one full turn 360, another full turn 720, another full turn 1080. If you go another full turn, that would be too big. All right, 4 full turns would be 1440 degrees. That means that you only need to go 3 full turns. Oh, 2 full turns rather. Why did I say 3 full turns? 720 degrees. All right. You don't even need to get through 3 full turns. I just realized. Okay. So that would be 305 degrees. Is that right? Or 3? That's right. No, 315. Because 315 plus 720 is 1035. Okay. Now, what would be the trig ratio for 315? Well, that is also quite hard, but we know that 315 would be in quadrant what? In quadrant 3. All right. So let's see. I'm going to make a quick picture of this. $315 would be 90, 180, 270. So maybe here, something like this. There is your 315. And what do you notice? I think you could get the reference angle, right? And the reference angle would be, again, that positive acute angle, which has the same terminal arm as this one, coming from the x-axis. So it's this one here. And that would be 45 degrees. All right, that is your reference angle. Why did I want to get the reference angle? Because the reference angle would have the same trig values as the principal angle, but you just have to remember that you will adjust the sign of the trig values depending on the quadrant. All right. In quadrant 4, as you can see, the terminal arm is in quadrant 4. In quadrant 4, cosine is positive, sine is negative. All right, and tangent is negative. Okay, so sine 45 degrees is root 2 over 2. But since we are in quadrant 4, therefore, sine of 315 is negative root 2 over 2. Okay? Now, cosine of 45 is equal to root 2 over 2. Therefore, cosine of 315 is also root 2 over 2 because cosine in quadrant 4 is positive. Now, tangent of 45 degrees is root 2 over 2 over root 2 over 2 is just 1. Okay? But then since it is in quadrant 4, tangent of 315 is negative. Are we good? Okay, that's it. Check your understanding. Oh, no. Sorry, did I answer all of those? Okay. Um, Determine the approximate values of the trig ratios for 1035. So it's still going to be the same ones, okay? But then it is going to be given in uh, uh, decimal. So this one, if you use your calculator, it would give you about um, 0.707. This one would be about negative 0.707, and that would be about negative 1 still. Okay. Check your understanding, number 4. So, given that sine of the angle is negative 5 over 13, sine of alpha equals negative 5 over 13. What are the other trig ratios of the angle alpha? So, first, you might be thinking, what is this symbol right here? This one. What is that? Well, that is just a Greek letter. That's alpha. Okay. So if that is sort of confusing you, well then don't bother about it. Think of it in terms of sine theta. Okay, because this is something that you are familiar with. Alpha, theta, beta, whatever Greek letter they use, it's really the same thing. It's just a name. Okay. Um, as you think about what the angle theta is going to be, begin by asking yourself, in what quadrant is your theta going to be, knowing that the sine ratio is negative. All right. So once again, we think about uh, gosh. All right. So okay, in cast in quadrant 4. All right. Cosine is positive. Cosine is positive. In quadrant 1, all trig ratios are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. So what I just wrote is the idea of cast, wherein it is a way of remembering what the signs are of the different trig ratios. So that means whatever it is that I did not write in each of those quadrants, it means it's going to be a negative. So where is sine going to be negative? All right, not in quadrant 1, not in quadrant 2. Sine is negative in quadrant 3. All right, sine is negative. In quadrant 4, also sine is negative. Mhm. Therefore, our angle would be in quadrant 3 and 4. Okay. So what do you have to do now? Now that we know that uh, our angle is in quadrant 3 and 4, so now we can proceed to get the cosine and tangent. Okay. Now if sine theta is negative 5 over 13, what you can do is think about it this way. Okay. Um, Sine is opposite over hypotenuse. How does that look like? Negative 5 over 13. Now, there is a right triangle wherein your opposite side is going to be negative 5, and then your hypotenuse is 13. So maybe if you're going to draw that, this is negative 5, okay? And this is 13, all right? So your picture would be something like this. There is your right angle, and there is your theta right here, and the opposite side is this side, okay? And this one is your hypotenuse, okay? So that means if you do the Pythagoras for, and you were looking for this side here, you will see that 13 squared equals negative 5 squared plus x squared. Now just solve it using Pythagoras, and that would be a 12. I mean, you should be able to do that, all right? So this is going to be having a length of 12, right? That means that this one really is negative 12, if you know what I mean, all right? Since it has a measurement of 12. Since we already found our opposite side, that would be 12 over 13. But since we are in quadrant 3, it is going to be negative 12 over 13. Okay? Uh, what about in what about in or tangent? All right, what about tangent? Well, tangent is just opposite over adjacent, which is negative 5 over negative 12, which is positive 5 over 12. Okay. Now we understand that what we have gotten are the trig ratios for theta when theta is terminating in quadrant 3. What about when theta is in quadrant 4? We already know that we are talking about two angles, quadrant 3 and 4. So it would probably be looking something like this. Okay. There's your other theta. So you will notice that the values are pretty much the same. Sine theta for quadrant 4 is still negative 5 over 12. Cosine theta, if you use Pythagoras, you will still get 12 over 13. All right, and then you ask yourself, what is the sign of cosine in quadrant 4? It's going to be positive. And what is tangent going to be in quadrant 4? It is going to be negative. So there are your values. Okay. Now what is the next one? To the nearest degree, determine the possible values of alpha when alpha is between 0 and 720. All right. So what you're going to do is you're going to do inverse trig of any of these values. Okay. So let's try cosine inverse of um, uh, cosine inverse of 12 over 13. All right. Now, if you do cosine inverse of 12 over 13, that would give you a reference angle. Okay. That would be 23 degrees. There is your reference angle. All right. This is the reference angle. Now, since your angle is in quadrants 3 and 4, therefore, in quadrant 3, your angle would be 180 degrees plus your reference angle, which is 23, and that gives you 203 degrees. Okay. Now, it says that our angle would be between 0 and 720. So that means another possible angle would be if you go another full turn, and then it would be coterminal to 203. So what would that be? So 203 plus 360 would be 563 degrees. Okay, with quadrant 4. Once again, our reference angle is 23 degrees. Therefore, in quadrant 4, theta would be 360 minus 23 degrees. And that would give you 337 degrees. And again, if you make another full turn, it will be 337 plus 360, which gives you 697 degrees. Okay. So that's all, folks. I think I have covered all of the check your understanding questions. I will have the homework posted on Google Classroom, so just check it out. Enjoy, and that's it for me. Until next time.